Welcome to the next lecture, dear students. This is Salman, Assistant Professor, Department of Mechanical Engineering, ISL Engineering College. In last lecture, we have discussed about the principal stresses on various oblique planes, so which is subjected to a single direct stress, two mutually perpendicular stresses, and one and shear stress, and one direct stress and one shear stress. Now we are going to see the last topic of this, so in which we are going to discuss about the shear stress acting on an oblique plane, which is being subjected to two direct stresses which are mutually perpendicular to one another, and a set of simple shear stress. So this is the first case where we are seeing more than two or three forces acting on a surface. So in this surface, in this kind of problems, first of all you have to consider a rectangular section whose thickness is unit 1 or unit. Generally unit is nothing but 1. So we are considering a rectangular section on which we are taking the two tensile stresses, that is one along the x-axis, one along the y-axis is acting, and we are considering a shear strain which is trying to rotate it in clockwise direction. So when we have already discussed, when you are trying to draw that, you have to take the directions. Here also I have done a small correction should be made here. I forgot to make it in the PDF. I have made it in my class notes. Hope you will see that. So always when you consider the stresses, these two stresses will be always in this direction, which I have tried to do here, but I forgot to do here. So these two should be like this, and these two should be like this. One going upwards, both the heads should be meeting to some point. So you should draw the shear stresses in this way only. Okay. So this is trying to rotate your oblique plane in clockwise direction. Clear? Now if you see how to solve this problem, already we have discussed that all the stresses should be resolved along your sigma n and tau direction. Sigma n and your tau direction. What is sigma n and tau are nothing but the normal stress acting on the oblique plane, and tau is the shear stress acting on the oblique plane. So how to resolve the forces regarding this? So for that we have to make a few assumptions or few drawings, resolutions on which sigma x should be transported to sigma n direction, and sigma x should be transported along tau direction. For that, in last lectures we have already discussed that sigma n is moving in horizontal direction. We should draw a line parallel to the tau which makes an angle theta. This is because these two are similar triangles like this. So this is your sigma which is traveling in this direction. So what I am trying to do, I am trying to draw a line which is parallel to tau. So obviously this will make an angle theta because this is a similar triangle as that of your oblique plane. So this is theta, means this will be obviously cos. So the perpendicular to it, that is nothing but the 90 degrees which I am trying to draw at the same point. So these two are parallel now. So sigma x cos theta and sigma x sin theta. So I hope I am clear with this. Similarly, there is a tau which is making an angle. Similarly, this tau already we have discussed how we are trying to do. Again, you try to travel the same like this. So this is your horizontal. So we have taken this angle as theta. So this is your 90 minus theta. This is your theta. This is your 90 minus theta. Okay. 90 minus theta. Now if you see, these two are perpendicular. This line and this line are perpendicular. So this will be obviously will become theta. So this is an adjacent side. So this will become tau xy cos theta. Now you take the direction. It is traveling in the above direction. So you should travel this way and this way. So that is the reason. So the perpendicular to cos theta, that is sin theta, we are taking. So that perpendicular how we will draw is nothing but from here you have to draw a perpendicular like this. So these two are parallel now, which are 90 degrees to one another. So this is sigma xy sin theta, this is sigma x cos theta. Clear? So next thing is another force you have to take. You have to consider all the stresses. So we have solved the AB section stresses. One is sigma x stress, another is tau xy. Similarly, here we have another two stresses which are sigma y and tau xy. Now how you have to resolve this is nothing but take this force, vertical force. Already we have drawn this. Here I have drawn. So this is your vertical line. We have drawn this line which is parallel to tau. This is my horizontal, since this is making my angle theta. So this is my alternate or vertically opposite angle. Sorry, this is not alternate, vertically opposite angle. So vertically opposite means this will be theta. But we need the angle with respect to the vertical. With respect to vertical. How we are going to take that with respect to vertical is nothing but this is theta. Obviously this will be 90 minus theta. This will be 90 minus theta. Or another thing, this will be my 90 minus theta. So this is my theta. You can see this. So this and this are again perpendicular. I will try to draw again. Try to understand this cleanly. If you are not able to understand, you can comment me or ask me separately. I will try to explain you. So this is my theta. This is my theta vertically opposite. So this is totally 90. So obviously this is 90 minus theta. Now this is my horizontal. See this. This is my horizontal. So this is 90 minus theta. Correct. So this is 90 minus theta. We have resolved this. But whereas we need the angle with respect to vertical, we have angles with respect to horizontal. So what I am trying to do is I am trying to take this vertical line. So this theta means this should be equal to theta. This is 90 minus theta, this is equal to theta. Now I am similarly extending this line. So I will get vertically opposite angle here, which is nothing but your theta, which is nothing but your theta. So that's why I have taken here theta. Now basing upon the direction is like it is moving in this direction. So you should travel either from here like this. Sorry. This, not those direction. You are trying to resolve with respect to sigma y, na? So your direction is downwards. Your direction is downwards. This is your direction y. Sigma y is in this direction. So you should travel this way, and from here you have to travel perpendicular. Okay. So that is the reason this is sigma y cos. Y means we have obtained the angle, this adjacent angle. So this is parallel line. So this is sigma x cos theta. This is sigma y sin theta. Sigma x cos theta, sigma y sin theta. We have resolved. Similarly, we have already obtained here theta. So which is same as theta here. So if this is theta, this is cos theta, and perpendicular to it is sigma tau y sin theta. Okay. Now we have resolved all the forces. So once you have resolved the forces, you have to stresses along the sigma n and tau direction. You have to take this line, very important. Resolve the forces along sigma x and tau direction. First we are trying to resolve with respect to sigma n, that is sigma n, and sigma n is acting on which area? AC, and it is acting on a unit thickness, that is AC into 1 like this. This is a unit thickness area. So that's why we are multiplying with 1. Similarly, the next, what are all the areas we are having? So which are in the same direction of sigma n, we should take it as minus. Which are in opposite direction, we should take it as plus when you are writing equal to. So see this is in opposite direction. This is sigma x sin theta. Both are in same. So opposite direction. So this is positive sigma x sin theta into, and this is acting on the area AB. Next is your tau xy. Similarly here you are having tau xy. See this tau xy and the sigma n both are in same direction. So it should be taken as minus tau xy cos theta into AB area. AB into 1. You have to write. I have not written AB 1 because 1 is keep on repeating. Next is this sigma y cos theta. This is acting on the area BC. So BC into 1. Similarly sigma y, this area, see this is also perpendicular. 1, 2, 3 and this one 4. So these 4 are in the direction of sigma n. That is tau xy sin theta BC. So once you get this, you have to set the AC on the other side. You will get sigma x sin theta AB by AC plus sigma y cos theta BC by AC minus tau x cos theta by AB by AC. We have already studied this from the triangle of oblique triangle, that is ABC. We know that this is my theta. So we have already discussed this in the last lecture. If this is my A, this is my B, and this is my C, what will be AB by AC? So that is nothing but opposite side by hypotenuse. That is nothing but sin theta. Similarly BC by AC cos theta, this is adjacent side by hypotenuse. Similarly cos sin you write sigma n sin square theta, sigma y cos square theta minus tau xy sin 2 theta minus tau xy sin 2 theta by 2, because what is formula for sin 2 theta is nothing but 2 sin theta cos theta. Here we are having only sin theta cos theta, so we divided by 2. So these two are repeating twice and both are having negative signs. So both are having negative signs. So we will take it as minus of, or minus 2 tau xy sin 2 theta divided by 2. So this is get cancelled. But whereas here we are having sin square theta plus cos square theta. We cannot have this formula because we are having the formula only for sin square theta minus cos square theta. Okay, or cos square theta minus sin square theta. This is sin square theta minus sin square theta plus cos square theta. We can make it, if we take both are equal, sigma x and sigma y are equal, we can take it as 1 because sin square theta plus cos square theta is 1. But whereas here we are considering sigma x and sigma y are not equal. Sigma x and sigma y are not equal. That's the reason we have to change it to 1 minus cos 2 theta by 2. This is 1 plus cos 2 theta by 2. Now we multiply into the bracket. So sigma x into 1 sigma x, sigma y into 1 sigma y. So sigma x plus sigma y by 2. In both this, what we are having common, cos theta, and here first minus is common, minus is multiplied with the sigma x, so I am taking minus common, so minus cos 2 theta. Okay, so what is left out, sigma x, this is plus, plus minus into minus plus, so we have taken minus inside, minus sigma y whole divided by 2, that is minus tau xy sin 2 theta. So this is very important formula in terms of 3 forces, 3 stresses. Similarly, in the direction of tau, tau is acting on which area you have to see. So tau is acting on the area of AC. So tau into AC, what are the forces in the direction of tau? So see these parallel forces. 1, I am rounding it now. 1, next is this 2, next is this 3, next is this 4. Okay, so this is sigma x cos theta, tau xy sin theta, sigma y sin theta, tau xy cos theta. Directions, so those which are in the same direction are should be taken as minus. So this is, and these are both in same direction, these two are minus, these two are plus. So tau xy cos theta and sin theta and sigma x cos theta should be taken as minus. They see here, okay, plus, and these two are minus. Now you have taken it. So once you have taken sigma x cos theta and it is acting on the area AB, sigma y is acting on the area BC, tau xy is acting on the area AB, and tau xy cos theta is acting on BC. So once you are done, you send the AC on this side. Again it will be like AB by AC. We know that from the triangle AB, opposite side by hypotenuse your sin theta, adjacent by hypotenuse is your cos theta. So this is opposite by adjacent, sin adjacent by hypotenuse is your cos. So once you are done with this, you try to resolve this. Sigma x sin 2 theta, sigma y sin 2 theta by 2 plus tau xy sin square theta minus tau xy cos square theta. This is what you have received. We have the formula for cos square theta minus sin square theta, so we have rearranged that as cos square theta minus sin square theta. Here we are having common sin 2 theta by 2. So sin 2 theta we have taken at common, and sigma x minus sigma y by 2 we have written. So here we are taking tau xy common and we are writing cos square theta minus sin square theta, because we are having formula only for cos square theta minus sin square theta. So cos square theta minus sin square theta is cos 2 theta. So for this we have obtained the value for tau. Now in this kind of problems, generally they will try to find you to tell you to find maximum shear stress. So maximum principal stress, not shear stress, maximum principal stress. So what is principal stress? In the first case we have identified principal stress is the stress on which shear stress should be equal to 0. So on oblique plane, what is shear stress acting? This is the shear stress acting on oblique plane. What is oblique plane? That we have already discussed. So this is the stress which is acting on the oblique plane. Now if I remove this stress, then we will have only sigma n. If I remove this horizontal stress, then we will having only normal stress. How to remove this? This is removed by making it 0. This is removed by making it 0. So I am trying to make it 0. Sigma x minus sigma y sin 2 theta by 2 minus tau xy cos 2 theta. So I am taking it minus value, I am taking it on the other side. So this will become plus. So both are plus now. Either you take it here. So sigma x minus sigma y by 2 sin 2 theta is equal to tau xy cos 2 theta. So sin by cos we know. So I am rearranging sin by cos or cos by sin. So sin by cos you know tan 2 theta. So sin is this. So 2 tan 2 tau x divided by sigma x minus sigma y. So here, so this both can be minus, then what happens? Both will be cancelled. If both are plus, then only it is positive. So first case I am taking both as minus, second case I am taking both as positive. Now see why I am taking this as adjacent side and hypotenuse is nothing but, we know that tan 2 theta is nothing but opposite by adjacent. Opposite by adjacent. So what is opposite side here? 2 tau xy. So 2 tau xy I am taken as opposite. Where is my 2 theta now? Here is my 2 theta. What I have written here? 2 theta p. What is nothing but 2 theta for principal stress. 2 theta for principal stress. So from that you are trying to calculate the value of sin 2 theta, sin cos 2 theta. First we will solve case 1 problem, then we will go for case 2. So this is case 1. So cos sin 2 theta value, we know that sin 2 theta is nothing but opposite by hypotenuse. What is hypotenuse? That is nothing but average of this. We know that what is the resultant of this two? Sigma x minus sigma y the whole square plus 4 tau x square y square. Yes, we have done it. So we are trying to cos 2 theta value I have find. So once you find this, go to sigma n value. What is the sigma n value you have got? Sigma x plus sigma y by 2 minus sigma x minus sigma y by 2 cos 2 theta minus tau xy sin 2 theta. So compare this. You are having sin 2 theta here. You are having cos 2 theta here. So cos 2 theta I am substituting this value. Sin 2 theta I am substituting this value. I am directly drawing this values. Okay. I am drawing this. Now this here. Okay. So substituting here, we are going to get minus of sigma x minus sigma y under root of sigma x minus sigma y whole square plus tau x square minus tau xy minus 2 tau xy divided by. Okay, done. So once you are done, minus into minus is plus tau sigma x minus sigma y into sigma x minus sigma y is whole square. This will not change. So this is repeating as it is. There is no change in sigma x plus sigma y by 2. So this is repeating as it is. So this is sigma x minus sigma y the whole square 2 under root of sigma x minus sigma y the whole square plus tau x square. Here minus into minus, again this is plus 2 tau xy x square under root of sigma x minus sigma y plus 4 this. Now you take out the LCM. If you see here, this is 2 times. If you observe these two values, here it is only 1 time, here it is 2 times. So when it is LCM we are going to take, so these 2 should be multiplied into the numerator, because then only it will become common. That is nothing but multiply and divide this value by 2. Then it will become 2 by 2. Now denominator for both the values are same. So this is 2 times, this is 2 times. But whereas this 2 and this 2 will multiply and this will become 4. Since the denominators are common, we can directly add sigma x minus sigma y the whole square plus 4 tau x square. Now if you see this, both the denominators, both are same. One is with root, one is without root. So what we can do, we can consider like this. Under root and whole square. Under root and whole square. So this under root and whole square, what they will do, it will cancel square and square root. Square and square root. Or one you can take, another thing you can take is, okay, so this is 2 times, we know that. Or if you are having 2 by 2, if you are having 2 by root 2, 2 by root 2, so what we can do to this, so above 2 can be written as root 2 into root 2, root 2 into root 2, like this, root 2 into root 2, then root 2 into root 2 will become 2, correct, whole divided by root 2. So what is the answer? So this root 1 root 2 denominator, above 1 root 2 cancel and root 2 will be left out. Similarly, this is having square without square root, this is with square root. So what is left out? Root of sigma x square minus sigma y square plus 4 tau xy whole square. This is 1 by 2 is left out. You can take this 1 by 2 inside. If this 2 goes inside, it will become 4, because you are taking it inside the square. So root of 4 is 2. So since it is coming out, it is 4. So sorry, 2. If it is inside, it is 4. That's why I am taking it inside. That 4 is nothing but 2 square, you can write. Whole square it will become. Here it is 4 by 4 it will happen. So that will cancel each other. This is your sigma x n value. This is one case where you are getting an answer as plus, where you have taken both the stresses are in opposite direction. Now case 2. What is the case 2? Both are positive. What is the both are positive? So what is the sin theta you are getting here? Sin theta is equal to 2 tau x divided by root of sigma x minus sigma y whole square plus. So here also positive, here also positive. So we will go to the equation and we will substitute directly the positive values. So how we are substituting? See, sigma n formula sigma x plus sigma y by 2 minus sigma x minus sigma y by 2 into cos 2 theta minus tau xy sin 2 theta. So sigma x minus sigma y, here instead of taking minus we have taken it as plus, because both the values are plus. Here also instead of taking minus we have taken plus. So when you multiply, same thing will be repeated. Only thing is, in these both there is minus common, that minus will come outside. So the equation is like, if you see the difference, so here it is plus, here before the square root, here it will be minus. So tell me one thing. So this is 1 plus something, 1 plus something. Either this whole value is like 0.1, then you are adding, if this value is totally 1, 1 plus this, you total under root you are considering as 0.1. Okay, so similarly here sigma n plus both are same, so only thing is sign is changing. 0.1, I am giving it as example. So tell me which is bigger, 1 plus 0.1 is bigger or 1 minus 0.1 is bigger? Obviously 1 plus 0.1 is bigger, because the answer of this is like 1.1, answer of this is like 1.1, whereas the answer for this is 0.9, answer for this is 0.9. So this is the above value is maximum. So what we do is, this we consider as sigma n max, this we consider as sigma n minimum. So there are few problems in which they directly ask you what is the maximum value of principal stress when they are acting with two direct stresses and one shear stress is acting. So you have to directly use the formula sigma x plus sigma 2 by 2, sigma y by 2 plus under root of sigma x plus sigma x minus sigma y by 2 whole square plus tau x square. Okay, so let us see the few of the problems on this based upon different the four theories. One is the direct stress, second is two direct stresses, third is pure shear stress, fourth one is one direct stress, one shear stress, fifth one is two direct stresses, one shear stress. Okay, so in this is a problem in your book at a point in a strained material, the principal stresses are, here they are directly saying these are the principal stresses. These are the principal stresses, means here no shear stress is acting. No shear stress is acting, or 100 ms, 100 megapascal and 50 megapascal, both tensile, find the normal and the shear stress. So since these are principal stresses, on this surface and on this surface there is no shear strain, but whereas there is only principal, that is nothing but only normal stresses, but normal or direct stresses are there. What is the direct stress acting on this? So the direct stress acting on this is 100, this is 50. Always you should consider this as major axis, major value, this we should consider as minor value. Most of the cases we do like that only. Sigma x is maximum, sigma y is minimum. So I have taken it as 100 megapascal, this I have taken as 50 megapascal. Then they are saying find the normal stress inclined at an angle of 60 degrees with the axis of major principal stress. Major means this is your major horizontal. So here I have done a mistake. So with horizontal it is making major principal stress. With an horizontal axis it is making 60 degrees angle. So this is, you should take it as 60. I have taken it as 30. This is 60. Okay. Find the normal stress inclined at 60 degrees with the axis. Yes, with the axis they are saying, with the axis. They are not saying with the plane. If they say with the plane, you have to take this. With the axis, when they say you have to take it as this as 60. So if this is 60, so then you have to take the formula. What is the formula for when two stresses are acting? Is you have to remember those formulas. Sigma n is equal to sigma n plus sigma x plus sigma y by 2 minus sigma x minus sigma y by 2 cos 2 theta. When you are writing sigma n, so here you will get cos 2 theta always. Here you will get cos 2 theta. Similarly, when you write tau, you will write sigma x minus sigma y by 2 sin 2 theta. Okay, so try this. 2 theta is there. What is the value of theta here? 60. So what is the 2 theta you have to take? You have to take 2 theta is equal to 120. So that is sigma x 100 plus 50 divided by 2, that is 150 divided by 2, 100 minus 50, 50 divided by 2 cos 120. So you substitute this in your calculation, you will get. Next is 100 minus 50, 100 minus 50 divided by 2 sin 120, you will get the value like this. Okay. Now if they tell you to find the resultant, what you will do? Whatever the value you have got for sigma n and tau, both are perpendicular to each other. Horizontal square plus vertical square, you are going to get the sigma r value. Okay, clear? Now I hope you are clear. If you have any doubts, please ask me. a point is subjected to a tensile stress of 200 megapascal and 150 megapascal and two mutually perpendicular planes, and an anti-clockwise shear stress is acting on 30 megapascal. Determine the value of normal and shear stress on a plane inclined at major axis. So if you see the anti-clockwise shear stress of 30 megapascal which is acting on this, so this is anti-clockwise, but we have discussed that when it is going in this way, obviously the shear stress acting on this plane will be clockwise itself. It is acting on the plane, you should consider as it is. So both the cases is same. The formula is, we have to remember, sigma n is equal to sigma x plus sigma y by 2 minus sigma x minus sigma y by 2 cos 2 theta minus tau xy sin 2 theta. Here it is cos, means here it is sin. You can remember this first case, sigma x plus sigma 2 by sigma y by 2 sigma x minus sigma y by 2 cos 2 theta. Once you have got cos here, obviously in tau you should get sin. So substitute the formula, 120 plus 150 by 2, 200 minus 150 divided by 2. Since they have given the angle, see the angle which would they have given. So find inclined inclined at minor axis. Inclined at minor axis, what is the angle? They are going to determine the value of normal stress, shear stress on a plane inclined at minor axis. So I think they have given the diagram this 30 degrees. I have not determined that. Okay, minor axis they are making 30 degrees. Okay, so minor axis is this. So here it is making 30. So obviously if it is 30, obviously this will be 60. You have to consider like this. Okay, theta is 60. You have to substitute the values. So 30 sin 120, 170 minus 25, 25 cos 120, 30, 120. So you will get this value. Similarly, tau is equal to this sigma x minus sigma y. Here, if it is cos here it is sin. Once you are sin here, this will be cos. Tau xy cos 120. So substitute this, you will get the value. Next problem. A tensile member is formed by connecting two wooden members subjected to, here there are two wooden members. This is a first wooden member. I have written 1, 2. So two wooden members we are trying to attach are as shown in the figure. Determine the safe value of force if permissible normal and shear stress at the joint is 0.5 megapascal and 1.25 megapascal. So the normal stress here on oblique plane and shear stress should be within this 0.5 megapascal and 1.25 megapascal. Okay, so these are the two cases. This is for sigma n, they have clearly said normal and shear stress on oblique plane they have given. On at a joint means this is the joint which is making an angle 60. This is given the diagram. So obviously this is my oblique plane. On this plane they are asking these are the stresses. So we have to write the formula. What is sigma? What is the force acting here? Only one force is acting. Because of this force, what is the stress generated here? Sigma x. That stress is acting in the tensile direction. Because of the load, there will be sigma x alone. We know the formula between sigma x and sigma n. What is that formula? Sigma n is equal to sigma x by 2 minus sigma x by 2 cos 2 theta. Sigma x by 2 minus sigma x by 2 cos 2 theta. Again I have repeated, in sigma n always it will be a cos theta. Okay, so what is sigma n value? We have got 0.5 mega. Mega is nothing but 10 to the power of 6. 10 to the power of 6 Newton per meter square. To convert into mm, we have to multiply with 10 to the power of 6 in the denominator also. That will get cancelled. It will become 0.5 Newton per mm square. Clear? So sigma x by 2. What is the value of this? If you see here, both are common. So you can write 1 minus cos 2 theta. What is theta value here? We have got 60. Substitute in the equation. You will try to get the value of sigma x as 0.67. Okay, so we will find the value of P. So 0.67 P by 200 into 100, P is equal to 13.4 kilonewton we are going to get. This is the one value. This is the value with respect to sigma n. But here another value is also given. Tau value is also given. So already you have calculated P value. Then what is the need of giving this value? Is nothing but you have to again calculate this. They are saying that this is not the exact value. This is the limit. Either this can be maximum, either this can be maximum. So I am trying to find the P value with respect to tau. So again by using tau value, tau, what is the formula? Tau is equal to sigma x by 2 sin 2 theta. What is the here? What we are having extra here is, so this sigma x by 2 is extra. So this we have to take sigma x by 2 sin 2 theta. You have to memorize those formulas. So tau is given as 1.25 sigma x by 2 sin 2 theta, that is sin 120. So once you write this, you will get the value of sigma x, where you are getting 2.86. With that you are going to get the p value as 57.2 kilonewton. Now which value you have to consider? Either we should get 13.4 or 57.2. Always the load should be considered whichever is less among the two values, because the maximum value, if I take 57.2, that this value will cross. Here sigma n will go beyond 0.5, which because of which my problem will get unsatisfied. If I consider this 13.4, whatever is the answer coming, that will, for the tau, that will be less than 1.25. It will not cross 1.25. That is the reason when you are having two values for the same number, whichever is the value lesser, you have to consider that value. That's why I am considering here 13.4 value as my acceptable value. Okay, because this is my safe stress. The last problem, most probably, if this is not next problem, stress at a point in a component are 100, that is one is tensile, another is compressive. Determine the magnitude in the normal and shear stress on a plane inclined at 25 with the tensile stress. What is tensile stress here? With this so which this is acting on this plane, so this plane it is acting, so with this line it should make 25, so it is 25 here. So what will be this with respect to minor? It is 65. That's why we have taken it as alpha is 25. Obviously 90 minus alpha is your theta, which is 65 with the minor. Okay, sigma n is, this is given as positive, another is given as, oh sorry, here I have done mistake, here it is compressive, here it is compressive. The direction should be taken as inwards, direction should be taken as inwards, direction should be taken as inwards, direction should be taken as inwards. So if you take this, sigma n is equal to sigma x plus sigma y by 2, sigma x minus sigma y by 2 cos 2 theta. This is minus because this is I have written here, but diagram I have made mistake, minus since it is a compressive force. So 100 minus 50 by 2, 100 plus 50 by 2 cos whatever is the angle, 2 into 65, 2 into 65. We remember this formula, sigma x plus sigma y by 2 minus sigma x minus sigma y by 2 cos 2 theta. So with this we will get the value of sigma n. Similarly for tau, sigma x minus sigma y by 2 sin 2 theta. So 100 minus of minus 50, 150 divided by 2 sin 130, you are going to get the value as 57.45, 57.45. Okay, so tau max is equal to 75 megapascal. Tau is minimum when sin 2 theta is equal to minus 1, sin 2 theta is equal to minus 1. So here in the problem they have asked us what is the maximum value of shear stress, what is the minimum value of shear stress. When it is maximum, because the sin theta's maximum value is 1, minimum value is minus 1. So maximum value we have taken as plus, so you will get it as 2 theta is equal to 90, theta is equal to 45. Substitute that 45 value, you will get the answer of tau theta. Next, when it is minimum, when theta is equal to minus 1. When the theta is equal to minus 1, obviously theta is equal to minus 1 is at 135 degrees, because all silver teacups, okay, 135, sorry, not 135, 225 I think. So 135 plus 90, 225, it will be negative, because we have this trigonometry, all silver teacups. So you remember, most of you will remember this, all silver teacups. So this is in third quadrant. Third quadrant means it should be like more than plus 90. So you have to add plus 90 to this. So that is like almost, you will get it for 135 I think, 135 or 145. Then you substitute that value, you will get this as minus 75. Okay, clear? So the last problem, element, an element is subjected to a tensile stress of 150 Newton and a shear stress of 50 megapascal, tending to rotate the element in clockwise direction. Find the magnitude of normal stress and shear stress inclined at an angle of 40 degrees with the tensile. Again here also they are saying it to with the tensile. This is a problem where when direct stress and shear stress is acting. Okay, so we will take down this problem, and they are saying here the shear stress tries to rotate the element in clockwise direction, tending to rotate the element in clockwise direction. So we have taken tau as minus 50. Okay, so theta we have identified. If this is 40, obviously with horizontal it will be 50. So we have to take that as theta. Horizontal is considered as theta. Now what is the formula for sigma n? Is nothing but sigma n by sigma x by 2 minus sigma x by 2 cos theta minus tau xy sin 2 theta. This is the formula. So once you write this, you know the value of sigma x 150 by 2 minus 150 by 2 cos 100 minus of minus plus sin 150 and sin 100. So you will get the value of sigma n. Similarly, tau. What is the formula for tau? Is sigma x by 2 cos 2 theta minus tau xy sin, sorry, tau xy cos 2 theta. Okay, so this is sin, this is cos. So you will write this tau value. We will get the answer as 65.5. Now they are asking for maximum shear stress. What is maximum shear stress? This value should be what, this 65.71 should be maximum. At what angle this will be maximum? Nothing but you have to identify this like this. So can exist when sigma n is 0. So when sigma n is 0 is another thing, but you have to make this sigma n as 0. You will get the value of sin theta by cos theta, because you know this sigma x and tau x. You will get the value of sin 2 theta. Once you got the sin 2 theta, substitute the values of here. You are going to get the value of tau xy, which I have done here. Tan 2 theta is equal to sigma x by 2xy, which is 1.5. 2 theta is equal to theta is equal to 28.15 or 118.15. You will get the tau as maximum. Now if you substitute 28 degrees here, you are going to get the answer as 90.13. 90.13. So with this we will stop, and we have identified few things, which these things we have identified by using analytical method. What is analytical method? In this all problems we have done it by mathematical calculations. Same problems we will do in terms of graphs. So that is nothing but more circle. With that your first unit will be completely finished. So that I am going to take tomorrow or day after tomorrow. Okay, thank you.